Hello, welcome to my channel. Today, the topic of my training is machine learning basics. Machine learning basics, and the software I'm going to use is Python. I will give relevant examples as we continue. And the IDE I'm going to use is VS Code. So, machine learning is a subfield of artificial intelligence. It allows computer to learn from data and make prediction or decision without being explicitly programmed for specific tasks. In traditional programming, we define rules and logic that computers follow to perform a task. However, in machine learning, we provide data and the model automatically learns patterns, relationships, or trends within the data to perform tasks such as classification, regression, clustering, and so on. What we are saying essentially here is that if you want to do machine learning, you are the one to provide the data, and what the data is being used for is for you to be used for training by your computer. So the machine you are referring to here is the computer, and it has to learn patterns, relationship, or trend, and that's why it's better than the traditional way of carrying out an analysis using regression and classification. So it's the machine that does that now. So the data, we have this to discuss. The data, we need data, we need model, we need training, we need prediction, we need evaluation. The end of the road to this one is evaluation. After you might have predicted, you must evaluate how well the model is going to perform. So data, the primary input for machine learning model is data, which can be in various forms such as numbers, text, images, and that comes under this, the kind of data we are going to input. So the model, a machine learning model is a mathematical representation that learns from the input data. Example, including linear regression model, decision tree, and neural networks. I'm going to talk more about this in subsequent videos. Training now. The process where the model learns from the data is called training. The model adjusts its parameter based on pattern it finds it in the data. So the training, the data is going to be broken to two. We are going to have training set, and we have the test set. The one is going to be used for testing. First part is going to be used for training. The training set will be higher. Some use 80% of the data to train the machine. Some use 75%, some use 70%, it depends. So when you use 80%, remaining 20 will be used for testing to see how well the training went. Is it going to be reliable? Now, prediction. Once trained, the model can make prediction or decisions based on new unseen data. You can see the new data might have come up from the one you have inputted. So after we have done that, you now go to assess that model before you now make, after you don't just train data and say you are just predicting like that and you are using the model like that. It has to be evaluated, and we have some metrics. We have metrics: accuracy, precision, recall, and so on. So we use all of this. Then the workflow of machine learning as follows. You can see data collection, you gather and process the data. This process data you see here is a lot of things we do here. When you gather the data, you still pre-process. And what do I mean? You edit, you clean, then you get it prepared for subsequent analysis. The model selection, choose an appropriate machine learning model. Here, how do you choose? We have a lot of them. You can see for classification, for regression, we have clustering. So all of them have their own model we use for them. So it is for you to choose. So we train the model using a training data set. Then you evaluate the model using the test data. I said the training, the data can go be broken to two. You have training data set, you can see. You have test data set. Then deployment. Deploy the model to make predictions in real world application. Any data you analyze and any model you come up with and you cannot make use of it in real world applications, of no use, I tell people. So you must prepare. Of course, you have a particular aim. You have aim and maybe many objectives before you embark on your machine learning. You don't just go into doing analysis without having any aim. Of course, so we have this type of machine learning. Machine learning can be broadly categorized into three main types based on how the algorithm learns and makes prediction. We have supervised learning, we have unsupervised learning, we have reinforcement learning. Although the first one is the most popular, followed by the second one. So let's explore each of this in detail now. For supervised learning is the most common type of machine learning where the model is trained on labeled data. You see, labeled data. In supervised learning, each training example is paired with an output label known as the target. The target we are referring to now is in a normal regression in statistics. Target is your dependent variable. Most time we denote it using y, and the independent variable here in machine learning, data science generally we refer to them as our features. And most time, see, you can see the way I put it here. So the goal for the model to learn the mapping from input to output. You may have many inputs. Yes, you may have x1, x2, x3, x4, many of them, and you are having just one output. Though we have what we call multivariate regression, where you have many outputs, but it's not common. Most time we are looking for just one output, but many inputs. We use that. People in engineering, people in Greek, you put so many things together, coming up with just one output. That's what we do. So, and that's why the reason why we have this as capital letter. You can see this x is written in uppercase, meaning that it's a vector or arrays of number where you have many of them, such as numerical or categorical value. Yes, it depends on the one you want to use. Is it numerical or categorical? Like gender now is categorical, status is categorical. But if it's numerical, maybe each of them continuous data like that. When we get to examples, you see what I'm talking about. Then output now. Output, most time I told you, see, output, they are labeled as Y, target values. Some call it response, some call it expected. You see, what you want to get, the outcome. You see, label or target values, such as class label or numerical values. The objective here, learn a function that maps input features to output label. Yes, that's the objective. That's what we do. So you want to see the function that we learn, that we map the two together. Don't forget, these inputs may be many. The output sometimes just one. So the type of supervised learning now, we are picking, say we are three, we are still in supervised learning. So under supervised learning now, we have types. First one here is regression. Many of us are familiar with regression. So when the output variable is continuous, for example, predicting house prices based on features like size, location. Before you can say, okay, you place price on your house you want to sell, you look at the location. You don't say, there are so many things that are responsible for that. The size of that land, then the location. In fact, location is very, very important in predicting house prices. So, for example, linear regression, polynomial regression. This regression, do I need to talk about it now? I move to this later. Linear regression is the one we do. Just normal regression where the power of the highest power there is just one. But polynomial, it can be quadratic, it can be cubic, it can be higher. That's what's called polynomial regression. Classification, when the output variable is categorical, you can see I've mentioned the gender, classify anything like maybe grade you come out from school. Classify emails as spam or not spam, you can see. This is just binary, spam, not spam. So example, logistic regression, decision tree, random forest, support vector machine. So here, logistic regression, all of these, they are under classification. All of these you see here, most of them, they have the variable here is continuous, just like you have put it here. Output variable is continuous, and this is what determines it. The output variable is what determines what type of supervised learning you are going to use. When the output is categorical, you use classification. So, and under that we have decision tree. All of these are common model we use for classification under supervised learning. So supervised learning examples here we have. Now we are through with this. Let's go to unsupervised learning. Unsupervised learning involves training a model on data that does not have label outcome. See, the first one has label outcome. This one does not have label outcome. The goal of unsupervised learning is to find hidden patterns, structures, or relationship in the data. See, you want to see the hidden pattern. Don't forget, the aim of machine learning is to train your machine to be able to follow a particular pattern. You observe the particular pattern trend embedded in your data. The machine will find it out and follow it like that. But here, unsupervised learning, because you are not, you see, this one is the outcomes are not labeled. So you see, once the outcome are not labeled, so even the pattern inside are hidden. So you want to now find out the hidden pattern structure relationship with that data. So you can see the input without label. Objective: discover pattern or structures in the data such as cluster or association. So the association, the cluster means okay, they come together. Those that have common attributes come together. So type of supervised learning now, we have clustering, we have association. We have the group. Now under clustering, we have grouping data points into clusters based on similarity. For example, customer segmentation. Customers that are very good, assuming you have a store or supermarket, you take data, those that come frequently, them, these are customers. So all of them may be from different city or from different area where you are, the location of that supermarket. And the time they normally come is in the weekend. They can be clustered together. Okay, those that buy a particular product, maybe what they normally come for, it. And those that come for that particular product from different area, they can be clustered together. So you have data for it. So now, because once they come in, they feel certain, you have given them what to feel, and you are expecting some response from them. You expect feedback from your customer. That's where you get their data. Example, I gave me clustering and hierarchical clustering. Association. Now finding relationship. We're talking about type of unsupervised learning now. Association now, I told you we have clustering and association. So under association, we have finding relationship between the variables in the data set, such as market basket analysis. You can see Apriori and ECLAT. So these are examples, and I can't go to detail of all of this now. Today is just for teaching, for you to learn the basic machine learning. The examples of this I will only give 1 or 2 later. Then subsequent video I'm going to show us detail of all of this. Then reinforcement learning now. RL. Anyway, you see RL is reinforcement learning. So it's a type of machine learning where an agent learns how to make decisions by performing actions in an environment to maximize a cumulative reward. You can see the agent receives feedback in the form of reward or punishment based on its action. You can see. So the input here, they are the current state of the environment. While the output are action to take to maximize reward. You can see, don't forget, input is the current state of the environment. So what is happening now? Because there's going to be an agent that's ready to learn how to make decisions by performing action on environment. You see, this one has to do with environment. What is happening now? What are we going to do to, you see, what are the actions to take to maximize the reward here? So there's going to be an agent that should take a decision, but it's going to be based on the input. So output will now be the action to take to maximize such reward. So objective to learn the optimal policy is strategic action that maximizes long-time reward. So there's data on that, and that's why in machine learning, data determines what to use. Let the data talk. There's this adage in those days, normality. Let the data speak. Don't force this data to, don't use any model for data. The data is safe. After proper diagnosis of the data, it will predict what's going to be used. So reinforcement learning often involves more complex environment and requires specialized libraries such as OpenAI's gym for simulation. So the example of this is gym library. All of the analysis we carry out in Python, we use library. Unless the library does not exist, and where it doesn't exist, we write our own program, we write our code for it. So it's not only in Python we use libraries. Even in R has, I don't know how many hundreds of libraries. So we use library to carry out all these tasks. So linear regression. Now we are picking one after the other now. I'm going to give you some examples here. So linear regression is a fundamental algorithm in machine learning used for making predictions based on continuous variable. Yes, it has to be continuous. The variable must be continuous. That's when you say talking about linear regression. It may not be linear. I must not force the data to be linear. It works by finding a linear relationship between an input variable and an output variable. I've mentioned it. Linear regression aims to find the best fitting line to represent that fitting line is in those days it's still the name, we call it line of best fit. That line that passes through those points, the point diagram for that, we call it scatter diagram. It shows, that line is the one that is the predicting line, and the closer those points are to that line, the better your model, because that's your prediction, and the farther away, the worse. So linear regression aims to find the best fitting represent the data. So this is the equation. So what's in physics, you know this. In mathematics, we know this equation of straight line. So the dependent variable is y, which you are trying to predict, which we call the output. You can say beta naught. Just wrote it like this in English, so that beta naught is this. This is the beta, and they are the parameter estimate. This one is the intercept. Yeah. So what your y will be when these ones are 0. So and beta 1 now, the slope of regression line, the estimate it tells you how much y changes on average of every 1 unit increase in x. So for every unit increase in x, so what will be the value of your y? That's what it means. See, then you have defined this. The y is the independent variable, which you also know as input variable. So epsilon you see here is random error term. This it is expected that the distribution of this is normally distributed. So okay, example now. Sample data on hours of study. I just use this as an example to demonstrate what I'm talking about linear regression. So you can see now these are the libraries we need to install. You can see sklearn is very important in data science as far as Python is concerned. So then as we are, you can install all of these libraries here, or you go to command prompt. How do you get to command prompt? CMD. You can see these command prompts. You just come here, you say PRG, whatever thing you want to, for example, numpy, maybe for example, numpy is the name of the library you want to install. pip install, install. Once you are connected with the internet, numpy. If I enter this now, I'm going to do the installation. So that's how to do it. Same thing if you want to install this, any of this, just pick it. Me, I've installed all of this. So now you can see the way I put it: scalar, model, selection, import, train test. So what you see here, this is the library name, this is the name of the library, this is the function. This the second one, name of the library is this is the function. Name of the library is this, then this is the followed by the function, the matplotlib, which does these ones are for advanced statistics, which we are doing now. You can see train test plot. I told you are going to break your data into two. Break your data into two. When you break your data into two, you have train test split. The train is goes is going to take a larger percentage of the data to train the machine. Test is to carry out prediction, to test what you have done. Then the linear regression is the function that will do the regression. The mean square error is for the metrics. The matplotlib.pyplot as plt is for drawing, for the visualization. Then numpy as np is to arrange the data, because that what does. Numpy does vector matrix, bringing up your data, just like your pandas. So here is an example. I generated this data. See, now sample data, hours of study as max scored versus max scored, hours of study. There should be a relationship between, it's expected, supposed to have a relationship between hours of study and max scored by student. I think it makes sense. Your mark you have in your class, you score in your class, supposed to depend on hour of study. Somebody who spend 2 hours, you can't expect such a person to have the same mark with somebody that spend 4 hours in the class. So that's what I did here. So now sample data is hours of study versus max scored. So the capital S you see here, you have all these are the hours of study. The score you see here, they are the scores. So somebody that's read for one hour, is getting 2 mark, 3 hours, 4 mark, like that. So just see that way, just an example. Now splitting the data into two, training and test set, very, very important. I said it, and what is doing that is this function, train test split. So after that, now if you have your own data, maybe from Excel, you can import it. You don't use numpy to do that, you use pandas. Pandas help you to bring in your data. Then after you have brought, because I'm just using for example, real life data, many of our data is either on Notepad or on Excel, you see, and so we split data into two: X train, X test. Note this very well. You have X train, you have X test. X train is the one I gave. Haven't I? Okay, yes, you can see test size. I say 0.2. That's 20% of your data. So I don't need to specify the train size, because the train size will automatically go to what? 0.8, which is 80%. If I'm using R, there's a way I'm going to do it. I'm going to write the 2. But in Python, you don't need to specify. Just specify test size. The second one is automatically chosen. So you can see X train, X test, Y train, Y test. You see, X train is going to be 80%. X test will be 20%. X train, you can see the Y train here will be the other one you're going to use to test. I mean, the remainder part of the train you have picked here. The same thing with for Y test. So you now initialize the model. What I mean here is that you now want to train, you now want to carry out the analysis. So the function doing this is linear. Don't look at the way I wrote it here. You don't use small letter here because it must not be different from the way you have defined it here. Otherwise, Python will give you a lot of errors. So then you now make the prediction. This model for this. So you are training the model here by using your X train and your Y train. You can see I pick from this. This is your Y train and this is your Y train. I'm not using test here. Don't forget, this is not test. You are training. This is you are still fitting the model here. So you don't use test. We use test only when you want to do the prediction. Note these ones very, very well. So now predictions, you have done that. Now you want to plot. What do you want to plot? You want to use this scatter diagram. The first thing that comes to mind when you are carrying out regression is to check. You know, this one doesn't require much. When we were in school in those days, you can use a pencil and ruler to see whether the data is even, do you have any relationship or not, by plotting ordinary scatter diagram. And what's mean by scatter diagram? You know, you have your Y, you have your X variables. You just plot your Y against your X without joining the line. Look at the scatter. That's why it's called scatter diagram. Look at where those points here. If they are following a particular trend, it is straight, you say yes, the relationship is okay. And if it's just scattered, you can't follow any trend. You know, you can say the relationship is low. So that's what we do. We do also in Python. You can see the way I put it. PLT here, you see, is on matplotlib. I say PLT. So the function here is PLT. I can use my name here, forget, but I'm using what every other person is using. So if I use my name here, if I put Isaac here, I must put Isaac here. Isaac dot scatter. It will do it. So dot scatter. Can see X, Y. You know we have defined our X and Y here. Can see. So X, Y color. I want color to be blue. I want for that of the line that we pass through, I want it to be red. Can see the label, that's the name. Anyone you see label is talking about the name of your chart. You understand? I want hours of study. The Y label, I want it marks scored. I can write anything here. Can see? You know, when you are putting it in quote, it means you know you are going to write. You want it to follow what you have dictated, and most time there are no rules here. You can say I put comma here. I mean I put spaces. You don't dare use space when you are writing code like that. But if it's label is allowed, even in starter and every other software we use. You can see. So now you want to show it, then you print it out. Call it prediction. So if let me run this, let me run it. Run. It's taking time. Yes, 0.5 seconds. Yes, you can see I've instructed it. Red. Don't know. Let me change this red to green. With green will show very well. Green. Okay. Green. Yeah. Yes. See green. I prefer it. Prefer it. So you can change this. Look at predictions. 8.807 2.9. Look at it. Those are the predictions. Why are they just 2? Because I pick 0.2 as my best size. You see? So that's 20%. You know, everything is just 10. So 20% of 10 will be true. Arrange data set. Arrange test data, predictions, and actual values on the table. You want to arrange everything. So what we normally do here, there are some data that you need to flatten. That I put this dot flatten here. There's predicted values, flatten it also to make sure that it follows what you want to have. This data, whenever you see data frame, either in R or Python, you want to create a table. df is data frame. I can use anything, but this is what most people use. So to have the same dimension, you have to flatten. Flattening means something that is horizontal, you want to make it vertical, or vice versa. So you want to write the output to an Excel file, where most people, when you teach them like this, they will tell you, okay, how we go to have this thing on our project, on our thesis. Let it be on Excel. You know, anything on Excel is accessible quickly. So when you are doing work for the people, make sure you know how to export it to Excel most time. So this is the function doing it. Very easy. df to Excel. To Excel is the function to Excel. Don't forget, if I use my name here, I must put my name here. Dot to Excel. To Excel is the one doing it. Now, for you to look at this one very, very well. Dot XLSX. You know, if you're going to use, well, maybe I should reserve this for another time. But you know, we have Excel has version. We have different version of Excel. Some use, it depends on the version anyway. Old version of Excel uses XLS. This new version is SLSX, and some is just CSV, comma delimited. Note the one you are using very well. Now, the print you see here, this is the title of the table. Now you can see I put here print df to string index is equal to false. You know, index means row in Python. If you don't put false here, Python will give you a Excel file, but we add certain values by the row side. You don't like it. That's why you say false. Now, this is an example. Built-in, another example is on built-in diabetes data. This one is online. You can get it. I downloaded this one online. It also came with Python. Yes, there's some data that came with Python. Something with R. So I'm using diabetes data here for you to see. You can see this is where I got it. SQL. Here you see SQL is talking about data science analysis. You see, and you know, it has its own data sets. So from this, import load diabetes is allowed. Import pandas as PD. So these are to get it. No stress. You can use it on your own system. You are going to get it. So I want to make sure of this example, because the one I did here, I generated it. This one I imported it. It came with Python itself. So convert to data frame, because this one cannot be used directly. So you have to convert it. You can load this one, you see how it look like. So you can see diabetes data columns, diabetes feature names. I told you what features are. Features are input variable. So the target here is our output. Diabetes dot target. Don't forget diabetes dot target. It means target is inside diabetes. The feature names, they are the output, the input variables. It's under diabetes. So you now display the first few rows. To display the first few rows, okay. If you want to display the first few rows, use df.edge. But I've commented it. I want to show the whole of the data. So that's why I commented it. I use df. So this one will show the whole of the data. Let me run it. Can you see? Age, sex, BMI, BP, SIS to S3, S4. So these are the data you can see. So, and when you are trying to show voluminous data like that in a Python, what it does is that it just gives you the first 5 and the last 5. And we hide, you see, so that's how it does it. But if I want to just show the first 5, the first few rows, what I need to do, I just comment this and uncomment this. Edge means the first 5, and as usual, Python will always give you start from 0. So if you have 500 rows, when you look at the last one, it will give you 499 because the first one will give you 0. So Now, if you want to show the first 5, we use head. If you want to see the last 5, you use tail. Let me run it for you to start talking about. You can see the first 5 because I use head. If I want to show the last, I want to show the last 5, I put tail. We use tail. You can see the last 5. That is it. So, okay, let me just show the last one. Right. So, let me move on. The last example I'm using here is built-in long-play data. Long-play data, just the way I use diabetes data. I'm going to use long-play. They are all popular. If you just type long-play data on internet, you will see a lot of things. It's not only in Python we use. You also in R and some other. I think MATLAB also. So now this is data set, and let me load the data. And load the data and see the data is not as voluminous as the other one that we use. So I'm just showing this for us to know that these ones are possible, can be used anywhere. So summary of machine learning. Supervised learning learn from labeled data, regression classification. Unsupervised learning learn from unlabeled data. Then this one learn by interacting with the environment. So conclusion. Machine learning is a powerful tool that enables them to learn and make decisions. Choice of learning methods, supervised, unsupervised, and reinforcement. All these libraries are used. So these bases provide the foundation for diving deeper into specific algorithms and use cases in machine learning. You can experiment with more complex models and fine-tune them for real-world application as you gain more experience. Thank you.